One of the most alluring concepts in futurism and science fiction is that of the Dyson sphere, where 100% of a star's energy can be harvested by encasing it inside a technological shell. While seemingly feasible variants of this concept exist, such as a Dyson swarm where the star is not fully encased but instead has thousands of energy collectors and habitats orbiting around it, the original idea of a full-on Dyson sphere itself may not be possible in practice. Building a complete shell would be a truly titanic undertaking, and it's unclear if the engineering needed for that is really within the realm of possibility. But there is another take here, that it might not even be necessary or desirable to build one at all, because there may in fact be a better alternative for power generation than a normal star. It may be that pulsars are more attractive energy sources than main sequence stars are, and there would be no reason to fully encapsulate one. One variation of the Dyson sphere concept is a Niven ring, named after Larry Niven's Ringworld novels. In that situation, you have a ring encircling a star rather than a fully enclosed shell, presumably because that would be easier to build. But pulsars emit energy in two beams, meaning that it's localized, pointed energy. You don't need an entire sphere to collect this energy. All you need is a ring. In a set of papers by Zaza Osmanov, links below, he details how a ring around a pulsar might function, and how that arrangement might prove advantageous for alien civilizations to use over a normal star. Not all pulsars are the same. The author details that fast-spinning pulsars would probably require rings too large to be practical, but slower-spinning ones might allow for a small, close-in ring structure on the order of a third of the distance between the Sun and Mercury. That would be significantly closer in than even standard Dyson shells would need to be to their stars, meaning that such a ring would require far less materials than you would need to fully enclose a star. The author goes on to point out that such a thing might be detectable in infrared if it were relatively close to Earth, and there are at least 64 known pulsars that are suitable for a look using current instrumentation. In the future, this list will expand, and the concept of building pulsar rings is just one more in a growing list of things aliens or future humans might do to generate power. But only a few years ago, no one would have thought to look for this kind of a structure around a pulsar. Because of that, this may actually dovetail into a solution to the Fermi paradox, that we simply don't know how or can't detect alien civilizations. The problem with pulsars is that unless their beacon-like emissions are pointed at us, we can't easily detect them. This means that there are a whole lot of pulsars out there that we don't know about. Well, can't easily see a civilization if you can't even see their star, or rather remnant of a star. In short, the solution here is that advanced aliens may find it more useful to use pulsars for power rather than stars, and we simply aren't yet well equipped enough or inclined to detect the megastructures that they build around those pulsars. For a civilization that is advanced but located too far from a pulsar to make use of one, they might still go the route of a Dyson swarm, sphere, or ring around a standard main sequence star. That should be significantly easier to detect, or is it? The trouble is, only a few missions to date have been suited to detect something like that, and then only coincidentally. One was Kepler, and it only looked at a tiny fraction of the sky for a finite amount of time, and IRAS, which looked at 96% of the sky in infrared. They turned up weird cases, such as the star KIC 8462852, where aliens were on the table as a possibility behind bizarre dimming events that the star exhibited, though that case appears at this point in time likely to just be dust in some unusual juxtaposition within that system. But that wasn't the only potential candidate Kepler found. KIC 12557548 also exhibited similarly odd dimmings, though less deep. In this case, it seems likely to be a disintegrating planet, but also in principle it could be a candidate for some type of alien megastructure activity. Likewise is the very odd light curve of the star Korat 29, but in that case, whatever is blocking the light seems to be planetary in scale, suggesting a planet, but what exactly is going on with it is still unknown. But perhaps most intriguing was a study of the IRAS data by Richard Kerrigan, linked below. He actually found 16 Dyson sphere candidates. Kerrigan recommended follow-up study, but to my knowledge this has never been done. These are unlikely to actually be Dyson spheres, and much more data is needed, but the bottom line is that even when we do have candidates, they don't always get any attention. In other words, Dyson spheres and their variants could be everywhere still. It could just be that they are a lot harder to see than we might have originally thought, and might not be commonly located around main sequence stars. Couple that with the inability to detect pre-industrial civilizations because they don't emit anything, and the difficulties of detecting alien radio signals, and the paradox could be solved through us simply not knowing what to expect from an alien civilization. Thanks for listening. I am futurist and science fiction author John Michael Gauthier, and be sure to check out my books at your favorite online book retailer and subscribe to my channel for regular in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live.